At 2:17 on the afternoon of August 9, 1943, Margaret Ashworth stood at Assembly Station 47 in the AV Row factory, watching a Lancaster bomber roll toward final inspection. 19 years old, 11 months on the production line, zero authority to change engineering specifications. The Luftwaffe had shot down 156 Lancasters over Germany that summer. RAF Bomber Command had investigated 89 catastrophic structural failures. 34 aircraft had broken apart in mid-air. The pattern was always the same. German flak scores a direct hit on the wing root. Wing spar fractures at the bolt connection. The entire wing separates from the fuselage in 2.3 seconds. 2.3 seconds was enough time for a Lancaster to fall 800 feet before the pilot could react. The crews didn't bail out. They couldn't bail out. 7 men trapped in a tumbling bomber, knowing exactly how they were going to die. Margaret had read the accident reports. She'd seen the metallurgical analysis. She'd studied photographs of wreckage recovered from German fields. The problem was the bolt specification. Standard assembly called for grade 5 bolts in the wing root connection, 6 bolts per wing, 12 bolts total, holding 65,000 pounds of aircraft together during 4G combat manoeuvres. Grade 5 bolts were designed for 120,000 pounds per square inch tensile strength. The engineering calculations showed this was sufficient. The calculations were wrong. When a Lancaster took flak damage near the wing root, explosive force created shockwaves through the airframe. The shockwaves concentrated at connection points. Grade 5 bolts handled steady loads perfectly, but failed catastrophically under impact stress. They snapped clean through. The Luftwaffe gunners knew this. German intelligence had analysed British bomber wreckage. They'd identified the structural weakness. They trained their gun crews to target the wing roots specifically. Aim for the connection point between wing and fuselage. One direct hit, wait 2.3 seconds, watch the bomber disintegrate. British engineers at the Air Ministry knew about the problem. They'd been working on a solution since March. A redesigned wing spar, stronger connection brackets, grade 8 bolts instead of grade 5. But the redesign required retooling 14 production facilities across England. Lancaster output would drop from 42 aircraft per week to 19. The Air Ministry couldn't accept that reduction. Bomber Command needed every Lancaster they could get. The strategic bombing campaign depended on overwhelming numbers. Harris, the commander-in-chief, had made it clear: maintain production rates at all costs. So they kept building Lancasters with grade 5 bolts, and Lancaster crews kept dying. Margaret worked the night shift at AV Row's Woodford facility. She'd been hired in September 1942. Part of the massive expansion of female workers after conscription took the men. Before the war, she'd worked at a textile mill in Manchester. 10-hour shifts, repetitive work, low pay. The bomber factory paid better, 42 shillings per week plus overtime. War work meant something. Making fabric meant nothing. She'd started in the fuselage section, installing oxygen lines and electrical conduits. After 3 months, they'd moved her to wing assembly. Wing assembly was skilled work. Precision tolerances, critical fasteners, structural components that kept aircraft in the air. Most of the women didn't last in wing assembly. The work was harder, the standards were stricter, and the foremen were less patient. Margaret lasted because she paid attention. She noticed patterns. Station 47 installed the wing root bolts, the connection that held each wing to the centre fuselage section. 6 bolts per wing, torqued to 450 foot-pounds, safety wired in pairs. The torque specification was posted on the wall. 450 foot-pounds exactly. Not 440, not 460. Exactly 450. Margaret had installed wing root bolts on 127 Lancasters. She knew the specification. She also knew that grade 5 bolts at 450 foot-pounds were operating at 87% of their maximum rated capacity. That was the engineering safety margin. 13% extra strength beyond normal operating loads. The problem was that combat wasn't normal operating loads. If you want to see how Margaret's unauthorized modification saved an entire Lancaster crew, please hit that like button. It helps us share more forgotten stories from the war. Subscribe if you haven't already. Back to Margaret. She'd brought something with her to Station 47 that afternoon. A small canvas bag, carefully hidden in her tool locker. Inside were 12 bolts. Grade 8 specification, sourced from the experimental hangar where they were testing the redesigned wing spars. She'd taken them 3 days earlier during a shift break. Stealing from the experimental hangar violated about 30 different factory regulations. If security caught her, she'd be fired immediately, possibly prosecuted for sabotage. Margaret decided the risk was worth it. Grade 8 bolts looked almost identical to Grade 5. Same thread pattern, same head size, same length. The only visible difference was a marking on the bolt head. 3 radial lines instead of 2. Unless you looked closely, you wouldn't notice the difference. Margaret was counting on that. The problem had started in June. Her cousin Peter flew Lancasters with 106 Squadron. Pilot, 23 years old, 14 combat missions over Germany. He'd written to Margaret in July, describing what happened to Flight Lieutenant Harrison's aircraft over Hamburg. Harrison had taken flak damage during the bombing run. The shell hit the port wing route. The wing had stayed attached long enough for Harrison to turn toward England. 30 miles from the target, the wing had separated. 7 men gone. Peter said the crews were terrified of wing root damage. They'd rather take hits to the fuselage, the engines, even the tail. Anywhere except the wing root. Because wing root damage meant structural failure, and structural failure meant everyone died. Margaret understood bolts better than the Air Ministry engineers thought she did. Before the textile mill, she'd worked at her father's machine shop. Small operation, precision work, custom components for industrial equipment. Her father had taught her metallurgy basics by the time she was 12. She knew that Grade 5 and Grade 8 bolts had different carbon content. Grade 8 had higher tensile strength, 150,000 pounds per square inch, instead of 120,000. That was 25% stronger. The engineering calculations said Grade 5 was sufficient. Margaret believed the calculations were wrong because the calculations didn't account for explosive shock loading. She'd machined the first set of Grade 8 bolts herself in the experimental hangar. Well, she'd modified existing Grade 8 bolts to exactly match the Grade 5 length specification. Standard Grade 8 bolts were slightly longer. She'd used a precision lathe to trim them to specification. The head markings she'd left alone. 3 radial lines. Anyone who looked closely would know these weren't standard bolts. Lancaster serial number ED588 sat at her station. Final wing root installation before the aircraft moved to flight testing. This bomber would complete test flights within 3 days, then deploy to an operational squadron. The ground crew had already stenciled S for sugar on the nose. Margaret opened her tool locker. Inside was her standard toolkit and the canvas bag with 12 Grade 8 bolts. She removed the bag, placed it on her workbench, pulled out the first bolt. Her hands were shaking. She'd installed bolts on 127 Lancasters. She'd never violated specifications before, never changed engineering drawings without authorization, never modified an aircraft component based on her own judgment. If the Grade 8 bolts caused a failure during testing, killed a test pilot, there would be an investigation. They'd find the unauthorized bolts. They'd trace them back to her. She'd go to prison. But if she did nothing, Peter's Lancaster would eventually take wing root damage, and Peter would die because the Air Ministry wouldn't stop production long enough to fix the problem properly. Margaret installed the first bolt. Port wing, forward connection point. The Grade 8 bolt threaded smoothly into the wing spar. She torqued it to 450 foot-pounds. The bolt seated perfectly. No visible difference from standard installation. She installed the remaining 5 bolts on the port wing. 12 minutes of work. Then she moved to the starboard wing. 6 more bolts, 12 minutes. Total installation time, 24 minutes. for a modification that either would save 7 lives or end her career. The quality inspector arrived at 3:15. Norman Webb, 20 years at AV Row, veteran of the Great War, zero patience for sloppy work. He checked every bolt connection personally. He used a calibrated torque wrench to verify tension. He examined the safety wire installation. He looked at the bolt heads. Margaret watched him lean close to the port wing route. He was looking at the markings, 3 radial lines instead of 2. He'd spotted the grade 8 bolts. Webb straightened up. He looked at Margaret. He looked back at the bolts. Then he signed the inspection form and moved to the next aircraft. He'd seen the unauthorized bolts. He'd chosen to approve them anyway. Lancaster ED-588, S for sugar, completed flight testing on August the 12th. Test pilot reported no anomalies. Control response normal, engine performance within specifications, structural integrity verified through high G maneuvers. The aircraft was cleared for operational deployment. On August the 14th, S for sugar was assigned to 467 Squadron, RAF Waddington. The crew was Flight Lieutenant David Shannon's team. Shannon, 20 years old, Australian, 11 combat missions. He'd flown on the dams raid in May, one of 19 Lancaster crews that attacked German dams with Barnes-Wallis's bouncing bombs. Shannon had survived the raid, earned the Distinguished Flying Cross, and been assigned as a flight commander in 467 Squadron. Margaret didn't know Shannon's aircraft was the one she'd modified. She didn't know which Lancasters went to which squadrons. She just knew that ED-588 had left the factory with grade 8 bolts in the wing roots and somewhere over Germany. That modification would either work or it wouldn't. Shannon's first mission in S for Sugar was August 17th. Target: the Peenemünde research facility on the Baltic coast, where German scientists were developing V-2 rockets. Bomber Command dispatched 596 aircraft, the largest raid in 2 months. S for Sugar took off at 247 hours. The flight to Peenemünde took 4 hours. German radar detected the bomber stream at 0130. Luftwaffe night fighters scrambled from 6 bases. The fighters shot down 23 Lancasters before the bombers reached the target. Shannon's Lancaster arrived over Peenemünde at 0147. Flak was intense. German gunners had concentrated 47 heavy batteries around the research facility. Standard procedure for Bomber Command: straight and level bombing runs at 18,000 feet. Hold course for 90 seconds while the bomb aimer lined up the target. 90 seconds of predictable flight path while flak guns tracked the bomber. Shannon's bomb aimer, flying officer Leonard Chambers, called corrections over the intercom. Left, left, steady, steady, bombs away. The Lancaster's bomb bay doors opened. 4,000 pounds of high explosive dropped toward the V-2 assembly buildings. The aircraft jumped as the weight released. Shannon began a banking turn to port, standard evasive action after the bombing run. The 88mm flak shell hit the port wing route at 0148 hours and 23 seconds. The explosion tore a hole 14 inches in diameter through the wing's leading edge, 6 inches forward of the main spar. Shrapnel penetrated the fuel tank. Aviation fuel sprayed into the slipstream. The blast wave propagated through the wing structure at 17,000 feet per second. Every rivet, every bolt, every connection point absorbed shock loading that exceeded design specifications by a factor of 3. The 6 grade 8 bolts holding the port wing to the fuselage flexed under the impact. The bolts deformed slightly. The thread stretched, but the bolts held. On a standard Lancaster with grade 5 bolts, the port wing would have separated. The bomber would have entered a flat spin. Shannon and his crew would have had approximately 4 seconds to process what was happening before the aircraft broke apart completely. None of them would have survived. Instead, Shannon heard the explosion, felt the aircraft shudder, saw the port wing fuel gauge drop to 0. His flight engineer, Sergeant John Buckley, was already shutting down the port inner engine, cutting fuel flow, activating fire suppression. Shannon pushed the control column forward, decreased altitude, reduced airspeed to minimize stress on the damaged wing. The Lancaster was flying, barely. The port wing had sustained massive damage. The leading edge was torn open. Fuel was streaming from the ruptured tank. But the wing was still attached to the fuselage, still generating lift, still controllable. Shannon flew S for sugar back to England at 8,000 feet, 160 miles per hour. Maximum structural damage speed. Any faster and the damaged wing would fail. The flight took 6 hours and 40 minutes. They landed at Waddington at 08:27 hours, with 14 minutes of fuel remaining. The ground crew examined the damage after Shannon shut down the engines. The port wing looked like someone had taken an axe to it. The leading edge was destroyed. The fuel tank was shredded. Hydraulic lines were cut. Electrical conduits were severed. But the wing root connection was intact. The 6 bolts holding the wing to the fuselage showed deformation but no fractures. The bolts had absorbed shock loading that should have snapped them clean through. The station engineering officer, squadron leader Thomas Carpenter, ordered a detailed inspection. He wanted to understand why this Lancaster had survived damage that normally caused catastrophic structural failure. The maintenance crew removed the damaged wing. They photographed the bolt connections. They measured the deformation. They checked the bolt specifications. 3 radial lines on the bolt heads instead of 2. Grade 8 bolts. Not authorized by engineering drawings. Not standard factory installation. Carpenter called AV Rose Woodford facility. He wanted to know why this Lancaster had non-standard bolts in critical structural connections. The factory investigation took 3 days. They traced ED 588's production records. They identified the assembly worker at Station 47. Margaret Ashworth, night shift, wing root installation. Margaret was called to the factory manager's office on August the 23rd. She expected to be fired. Possibly arrested. She'd violated specifications, installed unauthorized components, potentially endangered aircraft and crew. The factory manager, William Thornton, sat behind his desk reviewing production documents. Station engineering supervisor was there. Quality control inspector Webb was there. All 3 men stared at her for approximately 10 seconds before Thornton spoke. Miss Ashworth, can you explain why Lancaster ED 588 was assembled with grade 8 bolts in the wing root connections? Margaret had prepared her explanation. She described the accident reports she'd read, the metallurgical analysis she'd studied, the structural failures that kept killing Lancaster crews. She explained the difference between grade 5 and grade 8 tensile strength. She explained shock loading versus steady loading. She explained why the engineering calculations were wrong. She finished talking. Nobody spoke for another 10 seconds. Then Webb, the quality inspector, said something Margaret would remember for the rest of her life. The girl's absolutely right. Grade 5 bolts are insufficient for combat shock loading. Engineering calculations don't account for explosive impact stress. We should have caught this 2 years ago. Thornton asked if Margaret could source enough grade 8 bolts to retrofit the entire production line. She could. The experimental hangar had approximately 2,000 grade 8 bolts in various sizes. Half of them could be modified to wing root specifications. That would retrofit 83 Lancasters immediately. Thornton picked up his telephone. He called the Air Ministry. He explained the situation. He explained Shannon's Lancaster. He explained the unauthorized modification that had prevented a catastrophic structural failure. He requested immediate authorization to change production specifications from grade 5 to grade 8 bolts for all wing root connections. The Air Ministry approved the change within 6 hours. Every Lancaster in production would receive grade 8 bolts. Every operational Lancaster would be retrofitted during scheduled maintenance. The modification became standard specification across all heavy bomber production facilities, including Halifax and Stirling bombers. By August 30th, engineering teams were installing grade 8 bolts at 11 RAF bases. Each installation took 90 minutes per aircraft. Ground crews worked 18-hour shifts. The modification was invisible to aircrew, but the structural integrity improvement was measurable. Bomber Command tracked combat damage statistics meticulously. Every mission, every hit, every failure, the numbers told a clear story. July 1943, before the modification, RAF heavy bombers reported catastrophic wing separation in 19% of aircraft, sustaining wing root flak damage. Crews bailed out when possible. Most couldn't bail out fast enough. 127 aircrew died from structural failures that month. September 1943, after the modification, wing separation rates dropped to 2.8%. The few failures that did occur involved multiple direct hits or damage to other structural components. The Grade 8 bolts reduced wing separation deaths by 85%. The kill-to-loss ratio didn't change dramatically. German fighters and flak still shot down Lancasters, but aircrew survival rates improved. Damaged bombers that previously would have disintegrated now stayed airborne long enough for crews to bail out or reach friendly territory. More men came home. Flight Lieutenant Shannon flew S for sugar on 17 more combat missions. The aircraft took flak damage 6 more times, wing hits twice, fuselage hits 4 times. The port wing root bolts that had saved his crew in August kept saving them through the autumn of 1943. Shannon survived the war. He returned to Australia in 1945 with 93 combat missions in his logbook and a bar to his Distinguished Flying Cross. He never knew the factory worker who'd installed the bolts that had saved his life. Margaret continued working at AV Row through the end of the war. She was promoted to Quality Control Inspector in October 1943, the first female inspector at the Woodford facility. She supervised wing assembly for 847 Lancasters. Every aircraft left her station with Grade 8 bolts in the wing roots. 0 structural failures reported from aircraft she'd inspected. The modification spread beyond Lancaster production. The Air Ministry reviewed bolt specifications across all aircraft types. They found similar problems in Hurricane fighters, Wellington bombers, even transport aircraft. In every case, existing specifications used Grade 5 bolts in connections that experienced shock loading during combat. In every case, the solution was the same. Upgrade to Grade 8, the bolt modification became standard engineering practice. Post-war aircraft design incorporated shock loading analysis into structural calculations. Engineering schools taught it as an example of the difference between theoretical analysis and real-world performance. The calculations said Grade 5 bolts were sufficient. Combat said otherwise. Margaret received no formal recognition during the war. The Air Ministry didn't publicise modifications that revealed previous design flaws. Admitting that Lancasters had been flying with inadequate wing root bolts would undermine public confidence in the bombing campaign. So the modification happened quietly. Production specifications changed. Operational aircraft were retrofitted. Aircrew survival rates improved. No press releases, no ceremonies, no public acknowledgement. But the Lancaster crews knew. Word spread through Bomber Command faster than official communications. A factory girl at Woodford had figured out the wing root problem. She'd installed stronger bolts without authorization. She'd saved Shannon's crew. The modification that followed had saved hundreds of aircrew. Pilots and ground crew started calling them Margaret's bolts. Unofficial nickname, never appeared in technical documentation. But when a Lancaster came back with wing root damage and the crew survived, someone would inspect the bolts and say Margaret's bolts held. It became a thing aircrew believed in. Not quite superstition, not quite engineering. Just the knowledge that someone who'd never flown combat had cared enough to break the rules and make things right. Margaret's personal life remained separate from her work. She'd married Robert Ashworth in January 1942, before she started at the factory. He'd enlisted in the army, served with the 7th Armoured Division in North Africa. He'd been captured at Tobruk in June 1942, spent 3 years in a German POW camp. He survived the war and returned to Manchester in May 1945. They never talked about his time as a prisoner. She never asked about North Africa. He never asked about the bomber factory. They kept work and marriage in separate compartments. Margaret left AV Row in August 1945. The war ended. Bomber production stopped. Female workers were released to make room for returning servicemen. Standard procedure. She went back to textile work. Lower pay, less interesting work. She never complained. The war was over. That was enough. By 1946, she'd returned to the machine shop her father had owned before the war. Small operation, precision components, custom work for industrial clients. She spent 31 years there, eventually taking over when her father retired. She trained apprentices, taught metallurgy basics, explained the difference between tensile strength and impact resistance. Some of her apprentices went on to work in aerospace engineering. They remembered what she'd taught them about choosing the right fastener for the application. In 1968, a young engineer named James Aldridge was researching Lancaster structural modifications for a technical paper. He'd found references in Air Ministry documents to a wing root bolt specification change in August 1943. The documents credited field observations with identifying the problem. No names mentioned. Aldridge wanted to find the person who'd made the observation. He tracked down Squadron Leader Carpenter, the engineering officer who'd investigated Shannon's damaged Lancaster. Carpenter was retired, living in Cornwall, happy to talk about his RAF service. He told Aldridge about the factory girl who'd installed unauthorized bolts, about the meeting at Woodford, about the rapid implementation of the specification change. Aldridge contacted Margaret. She was 44 years old, running her father's machine shop, not particularly interested in talking about events from 25 years earlier. But Aldridge was persistent. He wanted to document her story. He wanted engineers to understand how practical observation had identified a flaw that theoretical calculations had missed. Margaret agreed to one interview. She explained her reasoning. She described the installation process. She confirmed that she'd violated factory regulations deliberately, knowing the risks. Aldridge asked if she'd been worried about the consequences. Margaret said she'd been more worried about her cousin Peter dying in a Lancaster with inadequate wing root bolts. The technical paper was published in 1969 in the Journal of Aerospace Engineering. Combat Shock Loading and Structural Fastener Specifications, a case study from Lancaster bomber production. It cited Margaret by name, first female factory worker credited in a peer-reviewed aerospace engineering journal. The recognition came slowly. In 1974, the Air Ministry released declassified documents about Lancaster modifications. Margaret's role was mentioned in the official history. In 1981, the RAF Museum at Hendon included her story in an exhibition about aircraft production. In 1992, she was interviewed for a documentary about women in wartime industry. She died on March 15, 2003, age 79. Survived by her husband Robert. 2 daughters, 4 grandchildren. The obituaries in British newspapers focused on the unauthorized bolt modification, the Lancaster that survived, the change that saved hundreds of aircrew. Her legacy lived on in unexpected ways. In 2008, the AV Row Heritage Centre dedicated a display to female factory workers. Margaret's story was featured prominently. In 2012, Lancaster ED588, S for sugar, was located in a storage facility in Australia. David Shannon's family had purchased the aircraft after the war. It was restored and placed on permanent display at the Australian War Memorial in Canberra. The port wing root still has the original Grade 8 bolts that Margaret installed in August 1943. 3 radial lines visible on each bolt head. In 2015, Manchester Metropolitan University opened the Margaret Ashworth Engineering Workshop for precision machining students. The curriculum includes a mandatory course on materials, science and fastener selection. Every student learns about Grade 5 versus Grade 8 bolts, tensile strength versus impact resistance, and why theoretical calculations sometimes miss critical factors that factory workers notice. The bolt modification itself became a teaching example. Engineering schools worldwide studied it. Simple component change, massive improvement in survivability, immediate implementation under wartime pressure, measurable, life-saving results, everything good engineering should achieve. Some universities kept original Grade 8 wing root bolts on display, small steel components in museum cases. Reminders that elegant solutions don't require complexity. Reminders that the people building the equipment sometimes understand the problems better than the people designing it. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every day. Stories about factory workers who saved lives with stronger bolts and brilliant observation. Real people, real heroism. Drop a comment right now and tell us where you're watching from. Are you watching from London, Sydney, Toronto, Berlin? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if someone in your family worked in wartime factories. Just let us know you're here. Thank you for watching, and thank you for making sure Margaret Ashworth doesn't disappear into silence. She deserves to be remembered, and you're helping make that happen.